Hello and welcome to another video of this series about object-oriented programming. In this hands-on video about class members denoted with the static keyword, I'll demonstrate in the IDE what they are and how they can be used in order to solve the problem we had with the implementation of chaining constructors in a previous version. As well will I explain the difference between static and final, because often variables are declared static and final. Although the functionality behind the keywords is not related at all, still people tend to be confused about their actual meaning and difference between the two. Now, before going back to that problem, let me first, as a recap, explain how I implemented chaining constructors in a previous version. What was the idea? So here's the rectangle class that we implemented. We have our four constructors: the default constructor, a copy constructor, a constructor with 2 parameters, and the constructor with 4 parameters. And the idea is that only the constructor with the most parameters, this one, will invoke the setters. The other ones will invoke this constructor using what I call the this invocation. So to come back to the example of the default constructor, so instead of calling the setters, we're going to invoke this constructor with most parameters, passing the necessary arguments. In this case 4. 1 for x, 1 for y, 1 for height, and 1 for width. And so this refers to actually the invocation of the constructor in the same rectangle class. And we do this for the copy constructor and for the 2 parameters constructor. And all that works just fine. But if we look at the implementation in the default constructor, in order for this to work, what I had to do is remove the declaration of these constants. Why? Well, let me uncomment those 2 instructions and I get a compiler error. And so the error says call to this must be the first statement in the constructor body. This is because at runtime we have to make sure that properties are initialized by executing calls to other constructors, if there are any, before doing anything else in the current constructor. This is doing anything else in the current constructor, so the compiler is not happy with this. But I wanted to use those constants because, among other advantages, it makes code more readable. So how do I solve this? Well, by defining the constants as class members and not local variables, as in this example. And this will be the new implementation in this new version about class member variables. Now, as usual, before anything, I'll create the necessary packages and then implement the solution in the new version. First of all, I'll make sure that the compiler error is not there anymore. Put it back in comments and then create the necessary packages. So in lib, right-click New Package, and then demo06 class member variables. Do the same in the app package, and copy the rectangle class from the previous version in the new version, and do the same for the client application. In the client application, I make sure that I'm importing the new version, so demo6 rectangle. Check whether everything works fine, so run the code. No compiler errors, and we have the same output as before. Time to implement the solution to our problem. In the rectangle class, in the default constructor, we can't use these declarations prior to the this invocation. Solution, define the constants, the finals, as class members. And first I'm going to create a new comment block, class member variables. The 2 finals from the default constructor, cut and paste. Uncomment. Now, what I just did is add 2 new instance members, minimum height and minimum width, 2 additional fields that will be part of every object in memory, together with the already defined instance members x, y, height and width. And then you may ask, is this correct? As explained in the introduction video, Minimum height and minimum width are not intrinsic properties of rectangle, as are xy height and width. No, minimum height and minimum width are just specifications that are used to make sure that every rectangle is drawn within acceptable limits, so applicable to every rectangle. In other words, we should have only one copy of minimum height and minimum width in memory, and not one per object. How do we achieve this? By making those variables static. Static min height, static min width. And by declaring them static, we call these variables class member variables. Not because they have class scope, because x, y, height and width have class scope too, so meaning that I can use them in every constructor, in every method where I would like to. The compiler is not going to complain. That is class scope. Scope is something that is managed at design time by the compiler. Class and instance member variables is managed at runtime, and that determines where in memory these variables are allocated. So instance members in every object, class members only once. So to resume, what makes the distinction now between instance and class members is this static keyword. Instance members are always part of an object. Class members are available only once in memory. Okay, now let's use minimum height and minimum width. So minimum height, I pass it now as argument in the disinvocation of the default constructor, and minimum width as well. I want to get rid of these 0 and 0 literals in the default constructor. So let's add a specification for minimum x and minimum y. Copy paste. Minimum x, minimum y, 0, 0. Minimum x and minimum y. And do the same in the two parameters constructor, because over there as well we had these literals. So minimum x, minimum y, and get rid of all the comment blocks. And here are our 4 constructors, chained and using class members. Just a note about final. I just want to make sure that you don't mix the meaning between static and final. The variables here are defined final because I don't want these values to be changed after their initialization. In other words, they are supposed to be constant. This has nothing to do with being a class member or not, or with being allocated only once in memory or per object. No, static does that. Final is something that is controlled by the compiler. So no code can be written and run that would change the initial value of that variable afterwards. So don't mix those two. And then one last thing is I'm going to make them public so the client can read them. And I can make them public and don't have to use encapsulations because they are final. So no one, not even any client, can change its value. Unlike with the instance variables, and not because they are instance variables, but because they are non-final, we made them private and encapsulated them in, so to speak, a public shell of getters and setters, and implemented validation in the setters to make sure that clients aren't trying to assign invalid values. The encapsulation is implemented because they are not final. But because my class member variables, apart from being class members by the static, they are final. So no one can change them, so I can make them public in a safety manner. Encapsulation is not needed. So let me do that with the other 3. What about the local variables in the setters used for validation? For example, set x, we have these 2 local variables. Well, I'll remove them and add the declarations to the class member variables section as well. Cut and paste. We already have -x, and so I'm going to add the declaration for max x. Public static And I'm not going to scroll up and down. First I'm going to add the remaining maximums here. A max. So one for y, one for height, and one for width. Max y is 1,000. So max height is 500 and max width is 500 as well. And then remove the remaining local variables in the setters. So scroll down, inset y, remove those two. And as you can see, the compiler doesn't complain at all because it uses the variables from the class member variables section. In the setter for heights and in the setter for width. Let's run again. So no compiler error and the output is exactly the same. Another interesting and handy usage of class members is that it can be used to count the amount of instances of a class. Let me demonstrate it with the following example. So I'm going to add a new variable, count. Make it public for now. I'm going to encapsulate it in the next version, and I make it static as well. So the purpose of this count is to count the amount of rectangle objects that have been created. So why static? Why make it a class member and not define it as an instance member? Well, ask yourself the question, is count an intrinsic property of a rectangle as are x, y, height and width? Does count describe a characteristic of a rectangle? The answer is no. Put in other words, we don't need a counter per object. We just need one global counter. If this difference between static and non-static is still unclear, I highly recommend you watch my Under the Hood videos about the usage of static versus instance, in which the difference is demonstrated visually. Back to our count. Now the idea is that count increments by 1 every time a client creates a new object. Where in code can we track the creation of a new object? In a constructor. Which constructor gets called every time a new object is created? In our case, the constructor at the last position in our chain of constructors, namely the one with most parameters, one with 4 parameters, because this one gets invoked by the others as well. So here we'll add count++. Let's use it in the client. Now, because count is static, so not linked to any object, we don't need a reference to an object in order to be able to use count. So even before the creation of any objects, at the beginning of the program, can we add as first statement in the main following printf. An amount of rects created, a new line, and now I want to use count, but count is declared in a rectangle class. So how do we access this count variable? Well, by prefixing count by the name of the class, rectangle dot. And since count for now is public, can I use it this way? Okay. Do the same at the end of the program. I put the creations of the objects together and run the code. So we have 0 rectangles created at the beginning. Then our 4 objects are created and displayed on the screen. And at the end we have 4 rectangles created. Now back to the count declaration. So what would happen if we would remove static? And this is what I'm going to demonstrate in the Under the Hood video of this topic. So in memory, I'm going to demonstrate what the difference looks like. So make it actually an instance variable. It should be in this comment block, but I'm going to keep it here for now. I get 2 compiler errors because I can't use them as class member variables anymore. So I need to comment the first line in main and the last line. The only way I can access count now is by using a reference variable. So what I have to do is print out. I'm just going to display the value. for rect1.count, and do the same for the other three. So rect2, 3, and 4. What do you think the output is going to be? Well, pause the video, try to predict it. So here goes, run. So we have the output of our 4 rectangles, followed by 4 times 1. This is not a counter per class, this is a count per object. Every object has its own counter fields, just as every object has its own x, y, height and width field. This is just another instance member variable, so each rectangle object has its own count fields. This is not what we want, so we make it static. We need 1 counter per class, not per object. Undoing my code, run, and it works as before. This for the implementation of this topic about class member variables, and time to tackle a problem we are faced with now. Well, defining non-final variables public, whether static or not, is not a good idea. We defined our instance member variables that are non-final private. We encapsulated them. The same holds true for non-final class member variables. From the moment a variable is non-final, whether static or not, it means that the client can read the value, okay, but it can change the value as well and corrupt our program. Let me show this in the client. Since I have direct access to that variable, let me just change that value. Rectangle count plus plus. You know what? I'm going to do it a few times. Let's run this. 0 rectangles created. That's fine. But at the end, 7 rectangles created? No, that is not correct. The client can just change that value as he pleases. This is something we should not allow. How? By encapsulating the counter. That's what I'll demonstrate in the next version, where I'll implement the same concept that I've used in version 3, namely encapsulation, but this time with this class member variable. Thank you for watching. If you liked this video, thanks for pressing the like button or subscribing to my channel. See you in the next video.